Okay, this is Unit 5, Lesson 7, which is still in the second part of Unit 5. Um, and we are solving systems of exponential, logarithmic, and linear equations. Now, this is not anything new. It's really taken stuff that you learned before and put it all in the same kind of problem. So, just to review real quick, what does it mean to solve a system? Okay, to solve a system, or maybe I should talk about what is a system first. What is a system? And a system is basically when you have two or more equations with two or more variables. Okay, we're actually going to just be doing two equations with two variables. When we've done this in the past, they've always been linear. We actually had a few that were quadratic. Okay, what does it mean to solve that system? That means that we're trying to find the point or points of intersection. And that was too long of a word for of intersection. And remember, it's a point, so that means every answer should be written as an ordered pair. Okay, you might have more than one ordered pair, but if you have one, your answer should be as an ordered pair. Now, we're going to do it one of two ways. Okay, actually, we're going to do it both ways. You have algebraically, and that's what we have done before. So I'm hoping that you remember that that means you either have elimination, where you combine the two equations to make a variable fall out, or you have substitution, where you solve for one variable and plug it into the other equation. And we're actually going to do both. I'm going to do an example with elimination and an example with substitution. So keep in mind that this is a lesson for group work. So what I am doing and leading you through all that, so if you want to pause at some point or if you already know how to solve it, try to solve it on your own and then pause the video, solve it, and then come back and check your work. So the first thing we have to do is solve each system algebraically. Then we're going to solve for y in each equation, and we're going to do that so that we can use our graphing calculator to verify the answer graphically. And this time, we're actually going to use the intersect method because we're going to know where that point of intersection is every time before we go and put it in our calculator. We've used the zero method previously, and that was when we really had no idea where they intersected. Okay, so let's go start off. We are going to solve this system algebraically. So to solve it algebraically, look at this, and hopefully you can see that this is an e to the x, and that's an e to the x. And then this is an e to the y, and that's an e to the y. So I have two expressions, or it's similar to what you've had before. 2x plus 3y equals 5. 2x minus y equals 3. So this one, when they're set up like that and the variables are lined up how we need them, it's actually going to be at best to solve it by elimination. So I'm going to subtract these two equations. So 2e to the x minus 2e to the x, well, that's the exact same thing, so they cancel out, and that was the point. We're trying to eliminate one of those variables. And then 3e to the y minus a negative e to the y is going to be 4. And that doesn't say e. That's going to be 4e to the y, and 5 minus 3 is 2. So hopefully you know that now we're going to divide by 4 because we're trying to isolate that y. So e to the y equals 2 over 4, which is 1/2. Then, this is what we've been practicing. How do we solve for that variable? We take the log of both sides, and I'm going to use the natural log because that base is e. Natural log of e to the y equals natural log of 1/2. And this is those problems that I like to refer to as my White House. What colors? Oh, I don't want that color. Sorry, I want this one. Okay? Because that's what we've been doing all along. All right? So, what color is a White House? White. ln of e to the y is, of course, y. So we know that y equals ln of 1/2. Okay, so now, as you remember, when you're solving equations, okay, and I'm solving that system and I found one variable, I got to go find the other variable. So I'm going to take this and I'm going to go plug it into one of those equations, and it doesn't matter which one. I'm just going to go to the top one. So that's going to be 2e to the x plus 3e to the ln of 1/2 equals 5. Now, let me go take an aside here, oops, and come up here, and remind you what we have talked about previously. And that is, y'all know that the ln of e to the 5th is 5. And y'all know ln of e to the 1/2 is 1/2. Okay, why are we able to do that? Because the natural log and the e, those are both our natural base function, but the logarithmic function and the exponential function are inverses of each other. So when I compose them like this, I get what I started with, hence my 5. So that's if I take the log of the exponential. Well, what if I take the exponential raised to the log? Again, I'm composing inverse functions, so my answer will be 5. Or if I wrote e to the ln of 1/2, it will be 1/2. So that's a little bit easier if you can remember that than getting a decimal and putting the decimal in, because things aren't going to come out so nicely. So hopefully you can see from here that the answer to this part right here is what I just did up here. So that whole thing is going to be 1/2. So this is going to become 2e to the x plus 3/2 equals 5. And how do we continue to solve that? We got to take the 3/2 to the other side. So 2e to the x equals 5 minus 3/2, and that's going to be 7/2, because 5 is 10/2, and 10/2 minus 3/2 is 7/2. Divide by 2, e to the x equals, divide by 2, multiply by 1/2, it's going to be 7/4. And we're back to where we were here. So we're going to take the ln of both sides. Ln of e to the x equals ln of 7/4. And so x equals ln of 7/4. So my answer is, I write the x coordinate first, which is ln of 7/4, comma, ln of 1/2. So that is the answer to part A. I have solved the system. And notice we never picked up a calculator to do that. Now, when we do part B, okay, whether you do it there or whether you do it, we'll keep going. So part B says solve for y in each equation. It does say state the domain for each equation, but I crossed that out for our lessons this time. So I have 2e to the x plus 3e to the y equals 5. Okay, and I'm trying to solve for y, so I'm trying to get this thing by itself. So the first thing I need to do is get rid of that, and I get rid of that by subtracting it. So I have 3e to the y equals 5 minus 2e to the x. And then I'm going to divide by my 3, so e to the y equals 5 minus 2e to the x over 3. And again, we're back to these kind of things. So e to the something, so I'm going to take the natural log of both sides. Ln of e to the y equals ln of that, which is 5 minus 2e to the x over 3. And so what's ln of e to the y? That's y. So y equals ln of 5 minus 2e to the x over 3. So I solved the first one for y, and you're going to understand in a second if you don't already know why we're doing that. Now I got to go solve that second one. So that is 2e to the x minus e to the y equals 3. Looking for that one by itself, so my classes, they said we want to move that one over. So that's negative e to the y equals 3 minus 2e to the x. And yes, you want to get rid of that negative sign because you'll do some calculations wrong if you don't. So we're going to go ahead and say e to the y equals, now, if I divide or multiply everything by negative 1, that becomes negative 3 plus 2e to the x, which I'm going to write like this because I want y'all to kind of get in the habit. If I multiply this by negative 1, I just flip the order of it. And now I take the natural log of e to the y equals the natural log of 2e to the x minus 3, which then gives me y equals ln of 2e to the x minus 3. All right, so this is the second one. So I did part B. Part B said solve each equation for y. So we solved it for y, and the reason we solved it for y is because part C says use your graphing calculator, verify your answer graphically. So when you do that, and before you do that, if you haven't already, you need to know what these decimals are because that's what the calculator is going to give you. So I'm going to put in, if you put it in your calculator, you'll find out that that is 0.56, and this is approximately negative 0.69. So that's what I need to get when I put it in my calculator. Now let's go put these in. So with your Inspire, I have the ln, which is going to be control e to the x, and I got to get out of my Sparnic 1 second there. And it's got to adjust. Let's see if it's ready. There we go. Control e to the x gives me my ln. And now, what I really like about the Inspire and anything that gives you that horizontal fraction bar, hit Control, divided by, and then you get your fraction, and you don't have to worry about your grouping symbols. Okay, so this is 5 minus 2e to the x over, what am I over? Over 3. All right, so I hit Graph, and there's my graph. And remember, we hit the Tab key to bring it up again, and this time I'm going to hit ln of 2e to the x, come back down, minus 3, and graph that one. So there, I'm looking for this point of intersection, and we've done this a lot, so hopefully it's easy for you to remember. We hit Menu, and then we hit Analyze, and this time we're doing intersection. And the lower bound is on the left side of it, upper bound's on the right side, and there's my intersection, which we had was 0.56 and negative 0.69. So we're good to go. So that's the first one, an example of elimination. And now I'm going to go to the back side and do number 4 because I think it's kind of a good way to help you through 3 and 5. So again, our first part that we want to do is look at it and decide whether I want to do substitution or elimination. So I hope you realize this is not lined up like that first one. So this is an example of I'm going to use substitution. I have it solved for y. So this one is in terms of y, so I'm going to go ahead and put the y in right here for that x. And that's going to give me e to the y plus y, which is 2y, plus 3e to the y equals 10. Now, I'm going to start off showing you a way to do this that I did in the classes, and then I'm going to show you how you can do it if you can understand it otherwise, and you can decide which way you want to do it, okay? If you don't recognize this and know what to do, then make a substitution and let a equal e to the y. Okay? That is this thing right here. So e to the y is right here, and e to the y is right there. So I'm letting a be that part. So then if I square it, a squared, that's e to the y squared, which is, what do I do when I raise a power to a power? I multiply them. So that's e to the 2y. And so hopefully you can see that that right there is right here. So that means that this equation could be rewritten with a's by saying a squared plus 3a is equal to 10. Now it's what you've done lots before, and that's a quadratic equation, so I need to bring everything to one side. A squared plus 3a minus 10 equals 0. And we factor, right, because it's going to be a, and then I'm looking for the factors of 10 that subtract to give me 3, which of course will be 5 and 2. I have plus 3, so I want plus 5 minus 2. And then we set each of those equal to 0, which tells us a equals negative 5 or a equals 2. Now, a is not what I'm solving for. What I'm solving for is actually a is e to the y. So I've got e to the y equals negative 5 or e to the y equals 2. Now, if you remember, I think it's easiest to remember it visually. What is our exponential function? It looks like this. E to the x, y equals e to the x, or however. But your general exponential function looks like this. Is there anything I can put in to make it negative? Any value for y? It's not ever going to be negative because it's 0 to infinity. So we get to ignore that one. And then we would take the ln of both sides. Ln of e to the y equals ln of 2. So y equals ln of 2. And y equals x, so that's going to mean that my answer is going to be x is the same thing as y, so it looks like this. Okay? Now, if you remember, let me write it up here real small and see if, okay? Kind of going with this thing. We also did things in the past that looked like this. If it said x to the fourth plus 3x squared, I'm going to go ahead and say minus 10 equals 0. Okay? And we learned that whenever this exponent times 2 gives me that exponent. Okay? 2 times 2 is that. Look here. What is the exponent here? It's a 1. Actually, I'm going to go ahead and write that. If this was a 1, 1 times 2 is 2. So whenever this exponent times 2 is that exponent, you have a quadratic-like equation. And we factored it like this. X squared plus 5 and x squared minus 2. But what I'm getting at, so whether you make the substitution, if you can recognize that this exponent times 2 is that exponent, then you can go ahead and factor it and say, oh, that's going to be e to the y and e to the y, because whatever it is on this one, that's what the first thing. This was a, so we had an a and a. And then you're taking your factors of 10. Actually, I skipped a step. Let me set it equal. Bring it over. So you would have e to the 2y plus 3e to the y minus 10 equals 0. And then that times 2 is that one, so that's my quadratic like. So it's e to the y and e to the y, and that doesn't say y. E to the y. So then we have plus 5 minus 2, and e to the y equals negative 5, or e to the y equals 2, which is where we were basically right there. So you'll end up at the same place. So, I mean, this is shorter, but if you can't see it, if this is easier for you, then do it that way. Okay? When you put that in your calculator, which we're going to go ahead and do, that's going to give you 0.69, comma 0.69. So before I do that, so that you can put it on your calculator, let's go do, that was part A that I did that was kind of lengthy. And part B, we have to solve it for y. So this one is already solved for y, so that's one I'm going to put in there. And now I have e to the x plus y plus 3 times e to the y equals 10. Okay, so this can be broken up. And some of y'all remember, some of you don't. But what makes us add the exponents is when we multiply the bases. So this really can be written as e to the x times e to the y plus 3 e to the y is equal to 10. So when you do that, okay, notice that we've just got this and this, you don't want to, okay, are in both terms, okay, and that's what I'm trying to get by itself. So I'm going to factor out e to the y, and I have left e to the x plus 3 equals 10. And I'm trying to get that by itself, so I'm going to divide by this. So e to the y equals 10 over e to the x plus 3. And again, solving for that variable in the exponent, so I'm going to take the ln of both sides. Ln of e to the y equals ln of 10 over e to the x plus 3. And so y equals ln of 10 over e to the x plus 3. So there is my second solving of the equation for y. So what would we do? Go to our calculator. I'm going to get a new page, Control Doc. I'm going to put a graph. The first one was y equals x. Boom. The next one, hit my tab button to bring it up. And this one is ln of a fraction. So I hit control divided by. And on top I have a 10. And on bottom I have e to the x. Come back down plus 3. And there's my point of intersection. So I'm going to hit menu, analyze, intersect, go on the left side, go on the right side, and I love it when our answers match. So there's our answer. So, um, as I have mentioned, that's the wrong button. Hit that button. Come on away. All right. So I have finished, and I've done 2 examples of this. The rest of y'all, you need to work together, and please keep in mind, you will have something like this on the quiz, so you want to practice these problems. Just because I've done it, go put it aside, and get a blank copy out. You can print it off the calendar and try the same exact problem that we did. That's how you ensure your understanding of it. Just like football players, basketball players, cheerleaders, ice skaters, whatever. You get a routine and you practice the exact same thing over again to be able to do it well. So I hope that helps. If you have any trouble with your calculator or anything, you may email me or come see me before school during the AM. Thank you very much.